export energy to the grid and do not import energy to the grid, that is actually the best situation you can have. Okay? And you deal with your own storage needs, etc. I don't know of anybody that has achieved that. It's kind of the same problem as being grid independent and truly being zero. Okay? In some ways, it's better to be attached to the grid so you can export to the grid, because if you're grid independent, all summer long that PV system basically sits idle because you need so much PV in the wintertime to keep that building running. Site is the next option at B. Imported supply options. You know, if I buy wood chips and I import those wood chips to my site and burn them on site, okay? That is C. Ethanol, biogas. There's a whole host of strategies there. And finally, you know, I'm not sure it's a terrible thing, but I think we do have to classify it properly. You can always buy your way out of it, right? And saying, I am going to invest in the utility, having large-scale PV, concentrated solar, wind turbines, and I'm going to buy into that and commit to purchasing that renewable energy. It's back to how you're spending your investment dollars. There's another one that kind of sits in here that I've heard about. Colorado State University built a wind turbine. They paid for it, and they put it on Excel's wind farm north of campus, 30 or 40 miles, I think. And they wheel that energy that they own to their campus. And that kind of somewhere is in this. They're sort of importing it, but it's sort of on their site. And that one's a little bit fuzzier to me. We haven't quite figured out how to deal with that one, actually. Owning an asset and then wheeling that energy. There's another piece of this that you have to consider, and a lot of people forget, is just because you put PV on your building and hook it up does not mean you have any right to that renewable energy. At least in the state of Colorado, I know that to hook up to utility grid and net metering, you basically offer up the renewable energy credits as part of the statewide portfolio, which obviously impacts the overall state emissions factors, right? You do not own those renewable energy credits at all, and they give you a check for that. But you cannot hook up unless you accept their check. And that's one of those interesting things. So they don't own those credits. So like at the lab, we've got a couple of megawatts of PV. In order to say that we actually have, you know, our websites powered by renewable energy and that kind of stuff, we have to buy back credits. Even though the PV is physically located on our building, and those electrons pretty guaranteed go into our building. Yes, sir.
So is the concern that somebody could go after D by using the solar that's on your roof?
They do, because somebody, you know, in some cases there are third parties that buy that, right? Or you've got state rebate programs, things like that. A lot of those come attached with selling those credits.
You don't double count.
And you've got to be careful that you're not double counting. Yep.
Do you sell the credit for the same amount that you buy it back? Or do you make
Usually when you sell the credit, you're selling, they give you a per kilowatt of installed capacity one-time check for capital expenditures. When you buy credits, typically you buy them by the kilowatt hour. So I guess conceptually over time, yes. There's also some interesting things. We actually figured out at the lab that the value of us selling those credits to Excel actually was more than the credits that we were able to buy off the street, and they're coming from Texas or somewhere. So we're making money on it.
That whole SREC sort of market structure is very complicated.
Very complicated.
And it's very state specific. And LEED actually addresses it under their stuff, basically saying they'll let you sell so many years worth of SRECs, right? And still consider the PV you put on your building toward your rating. But beyond that, then you're violating their rules. Do you guys have definitional rules in terms of the net zero? Because the whole SREC market can be huge in certain states, and it really dramatically affects the investment opportunity that people have in terms of putting megawatts of PV on top of buildings.
Yeah. The other problem is just a longevity issue, and that's where U.S. Green Building counts. That you have to have like a 5-year or 10-year contract, I think, on theirs, right?
Well, there's different pieces of that. If you put a PV on, they'll let you sell the SREC, but they won't let you sell more than a couple of years worth of it. Okay.
See, in our case, what we say is that you have to show that you have sufficient credits based on what has been sold, put back on the market. See, in the case of Colorado, you can't buy your own credits back because they get retired to the utility. It's a PUC thing.
You gotta buy it from somewhere.
You gotta buy it from somewhere else. So, or buy WindSource, which is another Colorado program. So, yeah, it is
Convoluted.
it is convoluted and very complicated, for sure. But you have to be aware of that the chances are if you stick a PV panel on your roof, you do not own those credits. And again, it does. It varies from state to state. Right? I don't even pretend to try to keep track of all that. Okay? But it is out there and you should be aware of it. Okay? So just some ideas here. So on the A category, we've got PV, solar hot water, wind located directly on the building. Although I really don't recommend that. People try doing that. And you've seen these really cool artist renderings with big windmills. And, there's all kinds of vibration and structural and other things that kind of go with that. There's some other, we talked a little bit about biomass. Some of it is where does that biomass come from? If you're producing it on site, you can use it on site, then you can consider it on site. So some of the other ones, whether it's adjacent, low impact hydro is another one that hasn't been mentioned. Other renewable energy directed, connected. When you get down into C, that's really assets that you have on site to convert it. Biomass, wood pellets, ethanol, biodiesel. And then D are these other things, kind of buying your way out of that scenario. So in that case, the good news is that if you're willing to spend the money, right, you can always do this, although it's not always the most cost effective. I'm going to skip over here. So just a little intro on our campus. This is still a make-believe building sitting there. It's a rendering. That's the building we're going to talk about after lunch. The one in the background is the one that has those CNSE elevators with the MR16s. And so you can see that we've got PV. If that PV were enough to power that whole building, then it would be a ZEBA on a site basis. So there it is, that roof of that building. We've got about 780 kilowatts sitting on that roof today. That wasn't quite enough, and so we've got a parking lot. And not only was the parking lot, but also on our site, we've got a wood chip boiler. Now, when we talk about zero energy for this building, we did not include the wood chip boiler. And that was kind of our buffer when we did the marketing, back to the marketing campaign on this, that all of the energy actually came from PV. And so, I'm sorry, I got the numbers off a little bit. Go back to here. We needed 787 kilowatts. So physically on the building, the 500. But then on the parking, oops. There it is. The parking, the first parking lot, the visitor parking lot, we have 100 kilowatts. Oops. This didn't happen. There's a parking garage that you'll see later that we put in here that also has PV that really services that building. Okay. So when we talk about zero on site, it's not on the building. It's the PV on the parking lots and the building itself. If we needed to, we could buy credits from that on top of that. And so it's just kind of, again, how you draw the boundaries, how you put those pieces together. All right, so let's just start a little bit on the decision process. I'm going to do this. Everybody see the board? So if you think about decisions now, decision-making process, and we have a typical building, and that typical building uses this amount of energy. Oops. Sorry. Didn't want to do that there. This building has a certain cost associated with it. And on the x-axis, it has a certain amount of energy saved. And every time I make a decision related to the building, so this is my code compliant building. Oh, that's another interesting thing I guess I didn't talk about. A lot of times people talk about, oh, I built you an energy efficient building. There it is, right? It meets all the applicable energy codes. What have you just done? You built
Built a building that at least break the law.
built the worst possible performing building that doesn't break the law. Right? And yet, a lot of times people equate that with energy efficiency. You know, that's an interesting marketing piece. But every time I make a decision, I've got 4 quadrants that fits into. Let's start up here in quadrant 1. I want to do things to my building that save energy and spend money. What do you want to do?
Higher efficiency stuff.
Higher efficiency stuff. Better stuff. That could be heating systems, cooling systems, windows,
Wall insulation.
dimming, more wall insulation.
Talking
Right?
first
In
cost.
fact, how do we justify the stuff?
Long-term cost savings.
Payback.
Lifetime,
Life cycle cost. Payback.
not fair.
You know? Return on investment. Right? All those other good economic terms. Right? In fact, we spend a lot of time worrying about that, but no matter what you do, what happens here? I have to spend more money. Right? The engineers love to sit in that box. Right? DOE loves to sit in that box. Right? Everything has to be cost effective. We develop new codes based on cost effectiveness. We do everything based on cost effectiveness. We do everything based on cost effectiveness. Right? Yes, but not payback. Huh?
But it depends on your time horizon.
Oh, so now we can talk about the time horizon, right? If you have a longer time horizon, then what happens?
You can afford more stuff.
You can afford more stuff. Who's paying for that? Where did you get the money?
Nice.
Not enough. Not enough. Right? In fact,
Going down.
okay, we'll put NYSERDA in there. I'm easy to deal with. Right?
Comes out of your energy savings.
Comes out of the energy savings, but you still have to put that capital up front, right? Somebody still has to come up with the money, right? But if I come up with the money, you guys will spend it, right? Oh yeah. And you guys will get a green, sustainable, low energy building.
With no hope of trim.
Absolutely. Okay. Now, what goes in this box here? What things can we do that waste energy and spend money? Lots. Give me an example.
24-hour services.
24-hour service. I hadn't thought about that. I'll put that up.
Too much light.
Yeah.
Too much light.
Excess ventilation there.
Aesthetics.
All right, so we got all that kind of, oh,
Aesthetics is weird.
oh, who said that? Who said that?
Aesthetics. Flexibility.
I didn't want to put a name to it, but
Electronics.
Okay, stuff, right? Services, stuff, right? But, you know, some of that stuff comes after the fact. But once you see the image of what your building is going to look like, you ever heard of anybody changing that? Right? Who usually controls that process? The building design process. Does the engineer control that process?
Not enough.
Does the owner control that process?
The architect.
Usually the owner doesn't have a whole lot to say, right? They see some pretty pictures. They get enamored, it feels good, right?
It's the designers.
So, I mean, fountains. You know, I like fountains.
Fountain inside the building wall.
Inside the building. Yeah. Don't worry, the dehumidification, not a big deal. Right? See, if you're in the Southwest, then you can claim that it's evaporative cooling. Right? But what happens is, design can sometimes be a struggle between those two, competing for those dollars, right? And part of what we need to do is how to put those pieces together. What happens down in this quadrant down here? How am I doing time-wise?
Owner cutting.
5 to 10
Okay.
tax.
What happens down here? What do we do to save energy, or to waste energy and save money?
Value engineering.
Oh, smart. We take all of the good ideas here and we move them down here. And we call that value engineering. Right? Less efficient glass, less efficient HVAC. Does this stuff ever go away? Right? It's much harder to get rid of this than this. Partly because the engineers, again, after years and years of beating, know that if they don't have stuff that can plug in and plug out of the building, right, then the thing will never come in on budget, right? Because nobody really has the money that you think they have. What about this quadrant over here? Good design. You think that's achievable? That it's achievable to save dollars and save energy? The example that I gave of Zion National Park earlier, right? The building was 30% less to build and yet save 70%. Right? That was things here. That fit in this quadrant. Now, what happens is that we can run optimization models. We can take our energy simulation and we can stretch buildings. We can put in different kinds of HVAC. We can swap windows in and out. You know, one of the problems with daylighting is there's a lot of extra skin. You usually have to make it long and thin and narrow to get the daylighting in. Right? Costs money. Right? So we've got some models that play with those things and stretch buildings in. And there's this